And we'll be talking about how we can publish the data that you'll be collecting during this course. Firstly, just a few words. What does a data manager actually do? So part of a data manager's job is to basically help you to manage and publish your data and access other published data in as easy a way as possible. So we do that by developing tools to automate certain processes and make things easier. Some data managers are attached to data centers and help data go in and out of them. And things like this. I work with a lot of satellite data at the Meteorological Institute and handle the flow of data from the European Space Agency into a Norwegian platform. And another part of data management, which is really important but often overlooked, is to communicate how scientists should be working with data and how they can use the tools that we're developing. In geophysics, people are pretty good now at working with data, particularly in meteorology and oceanography. But in other disciplines, like biology and geology, it's really in its infancy. So we need to really put emphasis on teaching people how to publish their data. If you have any questions throughout this, just speak up. I will cut the questions from the recording if you would like me to. I might not see you raise your hand, so just raise your voice. And I'm very happy for you to just ask questions as I go and interrupt me. That's fine. So you're on Svalbard, which is an incredible natural laboratory for doing research. And this also means that you're very lucky in that you're able to collect a lot of interesting data, which are the envy of other people who are less conveniently situated. And this data could be useful to someone else. So we're going to publish them. So who wants you to publish your data? First of all, it should be you. There's several reasons for this. You'll get to be the author on the data set. Your data can get cited. It's always nice to have something with your name on for all eternity, a little bit of immortality. But more than this looks great on applications, whether you're, especially if you're looking for jobs in academia later, job applications, funding applications. And even if you don't intend to stay in academia, the skills that you learn through publishing your data can be transferable to a variety of different things. How to code if you want to do that, be organized, things like this. I should mention my daughter is at home and sick and she's just called me. What do you want, Amelia? You have to come here then. So I might have to interrupt the lecture once or twice, but it will just be questions. She's old enough to sit and watch television. Pepper is babysitting. The other people who want your data published are other scientists. This provides them with more data that they can use and increases the efficiency on which we can do science. Academia can be quite inefficient in that when you're trying to tackle a question, people often go and collect out new data without exploring whether there's data already out there that they can go and use instead to answer those questions, which obviously saves time, money, carbon emissions, all of this. But often big data sets are required to answer some of the bigger questions, and some data sets are far too large for one person or one institution or one project even to collect. So, and finally, the more data we publish, the quicker we do that, the quicker they can be used again, and the quicker we can progress as a scientific community. One thing people often don't think about is that the general public also want you to publish your data. the public, through paying taxes, fund most of the data that you're collecting. So it's only normal that if they're funding something, they should also be able to access them. You will get a few people who particularly want to engage in science and might want to get involved. Maybe they can go and get hold of the data themselves. This could be for science communication. It could be for just general interests and hobbyists, all kinds of things. And one thing we're lacking of a lot in society nowadays is that you can have data-driven decision-making, and this all has to start with the data being available. And you might say, well, who really cares about my small data set that I'm collecting up here in the Arctic? Well, firstly, it's not for you as the people collecting or creating the data set to say which data are going to be in demand in the future. This can be very difficult to predict. And more broadly speaking, it's really difficult to, you'll be surprised at which data sets get used again in the future. We revisit field sites year after year on different courses. So you can think of your data set as the first of a, or not actually the first in this case, but a sample of a time series of data. And if we had been better at managing our course data for the last 30 years at UNIS, we'd have some really interesting and useful time series of data by now. So this is about preparing for the future and providing better data sets for future people who are on the same course. And if you're interested in collecting a certain type of data, chances are someone else, somewhere else in the world is also collecting similar data. And you can think of your data not in isolation, but as a contribution to a much larger collection of data that someone should potentially be able to use all together. And this download all button might sound like a thing of the future, but some data centers already have things like this, like the Global Biodiversity Information Facility, for example. And even in cases where this isn't possible, right now, we should think when publishing our data, not just what's possible today, but also what's going to be possible in the future if we publish our data in a certain way. Because data are likely to be useful for decades into the future, if not longer, not certain data sets anyway. This is only possible if we have fair data. I guess probably you've heard of this term, fair, but this has unfortunately become a bit of a buzzword. And when people say the term third, they often really, all they're really referring to is that the data are findable and accessible, and they often forget about this interoperability and their reusability. And often the findability isn't as good as it could be either, to be honest. So data should not be something that's available on request to the corresponding author, should not be in the supplementary materials of a paper. Your data are useful to someone who has never read a paper and perhaps in a completely different field of research. So data should be published to a data center that someone can search through and find data that they might be useful to them, but they're not necessarily already aware exist. But there are hundreds of data centers, so which ones should you choose? And the important thing to know is that not all data centers are equal. An analogy I like to give is that a good data center should work a little bit like Booking.com or any other search interface. You can imagine that each data set is like a single hotel or a room, and Booking.com is only useful because it's searchable. You can provide some dates and a location and find all the hotels that are available to you. And then you can filter by other parameters that are important for looking for hotels. And this is only possible because someone from each hotel has registered the hotel with Booking.com with a load of different metadata. And all the metadata from every single hotel has to be consistent between all the hotels on the website. So if you were running a hotel and you registered it on some website that isn't searchable, it would be mostly useless. No one would stay there unless they already knew the hotel existed from some other means. And this is the same for data. So a good data center should work like this. And I can show you an example from the Arctic Data Center that we run here at the Norwegian Meteorological Institute. You can go here, find data. And we have this interface. I'm not going into too much detail, but you can search on a map for where data have been collected, when data have been collected, some keywords, ideally from a controlled vocabulary. So everyone who's providing this same kind of data is using the same keywords. Who's been involved in things like this? If we compare this to some less good data centers that are being used a lot, I'm really picking on Zenodo and Dryad, but there are others that are equally bad. I pick on these because a lot of people are using them, and a lot of people are saying they're the answer to something. And just because a lot of people are publishing data there doesn't mean it's a good idea to publish data. I'll show you an example. So if you look here for seawater temperature data, for example, let's say I want to filter further. I can say this is a data set. This isn't the first thing that's wrong with Zenodo. It's not really a data center. You can publish all kinds of things to here. It's a good place to publish software, code, cruise reports, whatever. Anything you need a DOI for, but not for data. Let's say we want to filter this further. What options do we have? Well, some subjects, but none of them look particularly relevant. Certain file types, but if we want to find out where the data have been collected using some coordinates, or perhaps the year that the data have been collected, it's not really possible. So yeah, you can find data in Zenodo, but only if you already have the DOI. It's very difficult to find something that you're not already aware of. Trivago is a website that brings data from booking.com, hotel.com, and tells you on which site the hotel room is the cheapest. This is only possible because all the contributing websites register their hotels with the same set of metadata. And we can do the same for data. There are hundreds of data centers, and if you're looking for data, you shouldn't have to look through all of them. So data access portals aim to make all similar data available in one common place. This could be data that are specific for a certain region, like one we have on SciOS. This makes data available. Well, the aim is to make all data collected in and around Svalbard available in one place. And you could also have data access portals that focus on certain types of data. So there are a few here that are relevant, that are all specific to the polar regions. I'll show you how the SciOS portal looks. Looks very similar to the data center page we host at the Arctic Data Center. That's no surprise. It's the same software. But the point here is that SciOS is not hosting any data. It's just pointing to data in different contributing data centers. So all your data that you publish through this course should be available via here. Maybe I should talk a bit more about SciOS. Perhaps you haven't come across SciOS too much. SciOS more broadly is a Svalbard integrated Arctic Earth observing system. And it's a way to collaborate research on Svalbard, and has a particular focus on long-term measurements. So long-term time series of data. And it's a sister organization of UNIS, or daughter organization, or I don't know, something like that. So when deciding which data center you want to publish to, what you should really do is just check which data centers are contributing to these access portals. And if a data center is contributing to one, it should be able to contribute to all the access portals. There are certain standards that the data centers should be using to broadcast your data, and therefore any other access portal can just build on top of that. So you can find that here. We're just going to data, submit data. And there's a list of data centers here, which you can choose from. Not just Norwegian data centers, and this list is growing as well. Okay. So now we can find and access all the data, but does this make the data fair? No. We need to consider the file formats that we're using, and also, importantly, which conventions we follow within those files. So you might ask, what's wrong with something like this? Data in some tabular format, it could be CSV, Excel, whatever. First, temperature of what? Air temperature, sea surface temperature, what depth or altitude are these taken at? What are the units? When were the data collected and where? Who by? All of this information could be on a landing page, but if someone downloaded the file and sent it to you, you might not be able to access that landing page. We might not know where it is. And if 3 people were collecting the same type of data and you asked them all to create their own CSV file, would they look the same? And could you write a script in Python or MATLAB or R to read all 3 datasets in and process them in the same way? Probably not. And this becomes impossible when you build up to thousands and hundreds of thousands of datasets. So we need some kind of standardization that the same data should always be formatted and structured in the same way. So you have 2 options. There's Darwin Core Archives, which is mainly for biologists, so it's not too relevant to you, but this is for species data. Just useful to know that there's other formats exist. And there's netCDF files, which in themselves are not FAIR compliant, but if you comply with the CF conventions, that's for climate and forecast conventions, then your data are FAIR. These are mostly for measurements of the physical environment. I guess all of you or most of you have interacted with these once or twice before, but you can also use them for model results, point cloud measurements. And we're deciding which type of format you should be using to publish your data in. Try to ask first, is it possible to fit my data into one of these? Before asking, shouldn't I just use this alternative? Wouldn't this be easier? The advantage of these formats is that they have a standardized structure. So all similar data should be structured in the same way. They include metadata within the files. So one shouldn't have to look anywhere else or ask the corresponding author to understand anything about the data. This will save you time as a data creator as well, because you don't get asked as many questions. The data and the metadata conform to controlled vocabularies. A controlled vocabulary is a list of terms that's searchable online, and each term has a description. So the creator of the data can read that description, use that term, and the user of the data can also read that description, and they should then have some common understanding of the data. All this together makes the data machine readable, so it's possible to build services on top of the data. And these file formats are also software independent. It's not such a big issue with Excel files that you can probably still open in 100 years. But if you have model data in some software-specific file format, that's not a good idea. I'll do this quickly because I guess you've probably looked at NetCDF files before. But this is a basic NetCDF file I created. A lot of information on the left, so I'll show you through with some yellow boxes on the right. This file, we have 3 dimensions. It says that there's 3 points of latitude, 4 points of longitude, and 2 points of time. It doesn't tell you what those values are, just the shape of the data. You then have your variables, and we can break this down into coordinate variables, longitude, latitude, and time, and your data variable. So your longitude variable here, for example, I'm not sure if you can see my mouse, has a dimension of longitude in brackets, and we can see that these are all floating points, so there's decimal places. Whereas this variable here, sea surface skin temperature, this is a 3-dimensional array of data. So the data have a dimension of time, latitude, and longitude in that order. And this is actually one advantage of NetCDF files over, for example, CSV files, because in a tabular format, you're kind of restricted to 1-dimensional arrays. We then have all of these metadata terms. I'll show you where they come through from later. And so these are metadata that describe the variables, so we call these variable attributes. And we have global attributes below. And there should be a really long list of different things. Perhaps most importantly is the conventions. And we can see here this is compliant with the CF conventions, it's the Climate and Forecast Conventions, version 1.8. And the ACDD conventions, Attribute Convention for Data Discovery, version 1.3. So these are really important. It tells not only you as a person, but also a machine, which conventions have been used in the file, and therefore which terms to expect to see within here, and how to understand them, and how the data should be structured as well. So there's some useful links here. I'll share this later with you, but I'll just show you also some screenshots from the conventions pages. This is a CF conventions page. It's 262 pages long. You don't have to read all of it. You can think of this instead like a one-stop shop for all the information you might need about how to structure your data in order for it to be compliant with the CF conventions. So if you have any questions, you can go here and find the relevant section, or just use Control F and find a section of a document you're looking for. Within this, you'll see, for example, how you should encode data with a longitude coordinate and which attributes should be including. There's lots of different examples for different specific types of data in the appendix. This is the main reason why it's 262 pages long, is that there's lots of different examples now. And also importantly, we have the CF standard names. So this is a controlled vocabulary that you should assign for each of your variables. So each variable should have a variable attribute standard name, and you pick one of these terms from this list, searchable. And then anyone who's working with the same type of data should have the standard name written down, the same standard name. So the variable name you assign is not standardized, but the standard name is. So this is really useful for us if we want to build services to perhaps combine data from different files of the same type of data. In the appendix, you have a load of attributes you can use. It tells you whether they are suitable for coordinate variables, dimensions, data variables, or for global attributes as well in some cases. But the CF conventions are actually quite light on global attributes. So this is why we also refer to the attribute convention for data discovery. So discovery data, discovery metadata, this is just metadata that helps someone discover or find the data. So it can be things like a bounding box for the coordinates, when the data have been collected, some keywords, and so on. So you can read these and choose what to include. But recommendations are not so good for encouraging consistency between data sets. Much more effective if you have requirements. So at SIOS, we recommend you use these set of requirements. So all of these attributes are taken from the ACDD conventions, the attribute convention for data discovery. But instead, you have a list you can choose and include all the ones that are required and leave the ones that are optional if you want. Yes, and these are also requirements of SIOS. So if you're saying that your .netcdf file is compliant with the conventions, you should really be checking that your data actually are compliant with those conventions. So SIOS hosts a compliance checker. It's not the only one out there, but we do have one. So you can upload your file here and make sure that it is compliant with the CF and the ACDD conventions. And if it's not, it will spit out some error messages. You can go and make adjustments to your script and make sure it's compliant. So we as data managers often say that we want to build services on top of fair data or tools that you can use. But what do we actually mean by that? Well, this could be on-the-fly visualization, and I'll show you how easy it is to make a basic plot of data in a .netcdf file. So let's say you're using Python, you can import Xarray. You give it the URL of some data on OpenDAP in a .netcdf file. We'll talk about OpenDAP very shortly. You open the dataset, select your variable, .plot, and there you go. Very simple. It's equally easy to get data out of the data that have multiple dimensions and plot them. For example, data on a map. This is a data set of global surface temperature anomalies for every month. So this is a time series of data, so we might want to select data for a certain month. We can do that here. This creates a new Xarray object for that subset of the data. And then you can plot it in exactly the same way. It's not too hard either then to add some extra bit of code around this to build something that looks much nicer, like this. And of course, it's possible to add this kind of on-the-fly visualization to access portals and to data centers as well. So this is just an example of some satellite data plotted over Svalbard that you're seeing on and through the SIOS data access portal. So people who are interested in using the data can perhaps get a look at it before they even decide whether they want to download it. Also, just because you put data in a data center in an .netcdf file, it doesn't necessarily mean that someone has to download them into a .netcdf file. It's very easy to build services where you can export data into a CSV file like this. So you just import your modules. Xarray has a function open data to data frame, which automatically dumps it to a pandas data frame, which you can then just export into a CSV. So you can put data in a .netcdf file in a data center and the user can get a CSV file out, but that will not work the other way around. So people often say to me who are less familiar with netcdf files. Why are you making this hard for us? Why can't we just have a CSV file? I tell them, well, if you get a CSV file, you're going to have to spend time working out what every single CSV file means, because they're all different. If you learn to do one netcdf file and how to understand that, then you can understand all netcdf files, and you don't even have to download the data into netcdf files if you don't want to. Okay, OpenDAP. Has anyone heard of OpenDAP? Anyone used it? Just go on, maybe.
Yeah.
Yep, great. So OpenDAP is basically a way of allowing you to read and access data over the internet without you actually having to download it onto your screen or onto your computer. So a lot of data centers are now making their data available for OpenDAP in a threads server. So you basically just take this URL and you can dump it into your Python or MATLAB script, the same way you would take a file path to data on your computer. And the data, as long as you have internet access, you can access them through that. This is really useful, especially if you have much larger files, gigabytes of data. You don't really want to have to download this all. It also means it's very possible to have dynamic systems where you have time series of data where data is still being appended year after year or day after day. And you can just rerun your script. You don't have to change anything. You don't have to download anything, and you can continue to get the latest data. It's also useful if you're not really familiar with netcdf files, as it dumps out all the metadata. You also download the data in ASCII format, basically a text file. You can take just the variables you're interested in by using these checkboxes. And you can also take a subset of the data by entering some information in here. So, very useful. If I do have some time, I'd like to talk a little bit about granularity. So, granularity, how should you organize your data? How many files should you create? How fine-grained should your data collection be? So imagine you're part of a project that's deploying some instruments, maybe some weather stations or something like this. A lot of people are inclined to publish all of these instruments or the data from all these instruments together, maybe even in one file. But we've learned that we have to consider our data as a contribution to a much larger collection of data. If you're someone interested in using the data and you see all of these stations here, you're not really going to care which project or institution has collected those data. You just want to access them all together in as easy way as possible. And you might never have even heard of the projects that are responsible for collecting these data. So on large scales, the project kind of becomes, I'm not going to say meaningless to the data user, but it's an arbitrary way to collect data. So there's lots of advantages with publishing data with finer granularity. And what I mean by that is publishing each station or perhaps different variables, if it makes sense to separate different variables into separate data sets with separate citations and separate DOIs. Some advantages is the metadata. The metadata can be tailored to each file. So if you publish data for a whole research cruise, for example, it might show up as a bounding box like this, because in the discovery metadata, all you're including is the maximum and minimum latitude and longitude. It's very, very difficult for someone who's using the data to come along and see exactly where, which locations you've sampled within this. Whereas if you publish each CTD cast or whatever in a separate file, then each will show up as a point on a map like this. Smaller files are simpler. If you publish a single depth profile in a single file, you only need to use one dimension, a single coordinate variable, and then one variable for each of your data variables. Very easy to create, very easy to understand. If you publish all your profiles in a single file, you then need to add some more detail. You need to add at least 2 dimensions, one time, where the time is each time you've done a different cast. You need different coordinate variables, and then you also need data variables for latitude and longitude, instead of just using the discovering metadata, the global attributes for this information. I also sometimes see data published like this for the same type of data, where people include dimensions also for the latitude and longitude, and then each coordinate variable calls the dimension of its the same name. So latitude has a dimension of latitude, longitude has a dimension of longitude. I would advise against this. This creates problems when you're trying to extract subsets of the data. I don't want to go too much into that. But the main point I want to provide is that the more complicated you make the data, the more different ways there are to publish them, even when you're trying to conform with conventions. So keep each file as simple as possible. A simpler file tends to include a lot less empty space. Let's say you have 4 different depth profiles. Your depth dimension and also the coordinate variable need to encompass every single one of those depth profiles. Now, the problem is you might not sample the same depth for every single profile. Perhaps the seawater depth is different at different places. Perhaps you just are interested in different depths. And that means that then if you have your seawater temperature like this, you end up including a lot of, not a number of values in some cases. So this is inefficient in terms of space, and let's face it, it's just not nice to look at or use. And for all of these reasons, it's a lot easier to build surfaces upon simpler files where you have finer granularity. And this will eventually make it easier for the data user. You can still credit the project or expedition or course using parent-child relationships in data centers. So this is an example from some data that we've published at UNIS, the East Jordan Weather Information Network. So we have a parent DOI and citation. This is Lukasz Frank and Mariusz Jonasson. And then you also have children data sets, which each have their own DOIs. So you can imagine this being a single weather station somewhere within this box. And this is actually better also for transparency of data. Imagine you're someone using the data. Maybe you just use one of the weather stations. You could just use this DOI, one of the child DOIs, and then it's clear to someone reading your paper or whatever which data you've actually used and what you're referring to. If you have used all of the weather stations, then you can use the parent DOI. One thing people ask is, doesn't this make it difficult for people using the data to have to download lots of files? Well, once you learn how to use OpenDAP, this can be quite simple. So threads and OpenDAP, we also have a catalog XML file associated with this. So you can take this catalog XML and you can use a module called TDS catalog, which I forgot to import up here. And you can loop through each of the data sets within that catalog which is this here. And here I'm just opening them up and plotting one of the global attributes. But you can imagine that you can do lots more complicated things upon this. So not only do you not have to download all the files, you don't have to download any of the files. Oops. Yeah, I can help you publishing your data. There's some tools I will share around after. I guess we're probably going to have maybe a workshop later, or or maybe you'll just be able to contact me in your own time. I don't know what Plan Zero has for this. There's a number of different Python and R codes that you can use here. One that I'm working on at the moment is this NetGDF and Python from beginner to pro, which is going to be associated with the YouTube course as well. This isn't finished yet, but most of the code is there, and it should include all the information with descriptions on how to do different things with NetCDF files. If you don't like to code, it's also possible to create a NetCDF file using Rosetta. This is a tool where you upload some data in some tabular format, like CSV file, for example, and you go through a form and it eventually spits out a CF NetCDF file. Again, remember to check that your data are compliant with the formats you're saying you're compliant with, the conventions. And I also host a YouTube channel where you can scan this and smash the subscribe button or whatever they say. I talk about things like, why isn't this working? How to get data out of a NetCDF file, and how to write a NetCDF file, for example. So if you want to go and read those and have a look and following those along for your type of data, you can go and do that.